Hello and welcome to the Science Nap. Tonight we're embarking on a slow, soothing journey through time. It's a journey so far back that even the stars in our sky would look different, rearranged into unfamiliar constellations. We are traveling to a time when our planet itself was a stranger, its continents just beginning to drift apart like lazy, sun-warmed puzzle pieces on an endless blue sea. This is the story of the dinosaurs. We will gently trace their story. How they rose from the ashes of a forgotten apocalypse, how they came to rule a world teeming with life, and how they eventually, rather dramatically, made their exit. But please, don't worry. We will not be charging through the Mesozoic era like a stampeding herd of triceratops. There will be no jarring roars or sudden movements. This is a quiet stroll through ancient worlds. A narrative tapestry woven with science and wonder, designed specifically to help you unwind, to rest your mind, and perhaps even to drift off into a deep and peaceful sleep long before we reach the final fateful asteroid. Now, I do hope this video isn't too interesting. After all, the goal here is profound relaxation. But if you find yourself still awake by the time a Tyrannosaurus Rex makes its grand entrance, well, at least you'll come away with some truly impressive prehistoric trivia to share with your friends. A small reward for your curiosity. Before we begin our journey, if you find this kind of slow, calming science storytelling helpful, whether it sends you to sleep or simply settles your thoughts after a long wink, consider giving this video a like and subscribing to Science Nap. It's a small, quiet gesture that helps more sleepy souls find their way to this little corner of the internet. And just out of curiosity, I would love to know where in the world you are watching from tonight. Let me know in the comments. Feel free to share your local time. I love seeing the quiet, distant corners of the world where this channel reaches. Whether it's the stroke of midnight in Manchester, the humid evening air of Mumbai, or 2 o'clock a.m. in a sleeping Tokyo, you are very, very welcome here. So, let's begin to settle in. Perhaps you're lying in bed. The lights are low, and your pillow is just the right amount of squishy. Take a slow, deep breath in, and let it go. The dinosaurs are waiting. They've been waiting for a very long time, about 230 million years, in fact. We can certainly take our time. Chapter 1. The birth of dinosaurs and the dawn of a new world. Our story begins not with a bang, but with a profound and echoing silence, the quiet that follows the end of a world. Roughly 252 million years ago, a catastrophe known as the Permian Triassic, extinction, or the Great Dying, obliterated most life on Earth. It was the planet's most severe mass extinction, a true apocalypse that cleared the stage for new actors. Into this harsh, recovering world, dominated by a single, colossal supercontinent named Pangaea, a group of resilient reptiles called archosaurs began to thrive. And from this hardy lineage, the very first humble dinosaurs would emerge. They were not giants, nor were they rulers. They were small, agile survivors, equipped with unique biological advantages that would, over millions of years, allow them to inherit the Earth. Let us travel back to that moment of stillness, 252 million years ago. The cause of the Great Dying was most likely a series of cataclysmic volcanic eruptions in what is now Siberia, known as the Siberian Traps. For nearly 1 million years, these volcanoes spewed unfathomable amounts of lava, ash, and greenhouse gases into the atmosphere. The world's climate spiraled out of control. Oceans became acidic and lost their oxygen, suffocating marine life. On land, acid rain scorched the forests. A runaway global warming made vast regions uninhabitable. When the eruptions finally ceased, the planet was a ghost of its former self. Around 90% of all marine species and 70% of land vertebrates were gone. Imagine walking through a forest in the aftermath. There would be no birdsong, for birds had not yet evolved. There would be no buzzing of insects, as many had perished. No rustling in the underbrush, no croaking of amphibians from a nearby stream. Just the hollow sound of wind whistling through the petrified, skeletal remains of ancient trees, and the distant groaning shift of a reshaping world. If Earth had a reset button, that event was it. The stage was now cleared, desolate, but full of opportunity. and the world these first dinosaurs would be born into was practically a different planet. The continents had not yet scattered across the globe like jigsaw pieces tossed by an impatient toddler. They were all fused into one colossal landmass, called Pangaea, which stretched from pole to pole. This supercontinent was surrounded by a single vast global ocean named Panthalassa. In theory, you could walk from what is now New York to New Delhi without ever getting your feet wet. Just be sure to pack plenty of sunscreen. Life on Pangaea was incredibly harsh. The sheer size of the landmass created an extreme climate. Interior was a vast, arid desert, larger than any that exists today, swept by powerful monsoons that brought either torrential rain or years of brutal drought. The air itself was different. The atmosphere contained less oxygen than we are used to, making every breath a little more difficult. Volcanoes still belched gases into the sky, and massive lava flows periodically reshaped the terrain. The plants that survived were tough, scrubby things, cycads, ginkgos, and hardy ferns, all adapted to drought and heat. But even in this punishing environment, evolution began to experiment. From the few survivors of the Great Dying, new forms of life began to emerge. One group of reptiles, the archosaurs, or ruling reptiles, began to gain a significant foothold. This was a remarkably successful group, and it's a good name because from this single lineage would eventually come not only the dinosaurs, but also the flying pterosaurs, the crocodilians, and, millions of years later, birds. Archosaurs had some impressive biological upgrades that made them uniquely suited for this post-apocalyptic Earth, while other surviving reptiles, like the ancestors of lizards, still lumbered around with a sprawling side-to-side gait. Archosaurs developed more upright limbs. Their legs were positioned more directly beneath their bodies, allowing for more efficient, faster, and longer distance movement. They also had stronger, more efficient lungs, and some were even developing the early signs of a higher metabolism, perhaps even a primitive form of warm-bloodedness. While other animals struggled, archosaurs were quick, agile, strangely well-suited for a world in recovery. Among these early archosaurs was a creature called Euparkeria, a small, nimble predator about the size of a fox that darted between the rocks of what is now South Africa. It wasn't a true dinosaur, but it was a close cousin, and it gave us a preview of what was to come. It was lightweight, it could likely run on two legs for short bursts, and it was fast. The blueprint was forming. Then around 230 million years ago, in the middle of the Triassic period, the first true dinosaurs finally appeared. They were small, nothing like the giants we conjure in our imagination. Picture your raptor, a wiry little hunter from Argentina, no bigger than a greyhound. Trotting through fern-filled undergrowth, its sharp eyes scanning for insects and small lizards. Or consider Herrerasaurus, slightly larger, with a long, narrow skull filled with sharp serrated teeth, chasing down larger prey in the Triassic dusk. These early dinosaurs didn't roar. Their vocal structures were likely simple. They probably hissed, chirped, or croaked, making sounds more akin to angry birds or crocodiles than the booming monsters of cinema. At this point, dinosaurs were still underdogs. They shared the land, with a host of formidable competitors. There were other, larger archosaurs, giant amphibians that lurked in swamps like living bear traps, and strange synapsids, reptile-like ancestors of mammals that looked like something between a Komodo dragon and a badly drawn platypus. It was a crowded, dangerous world. So what helped the dinosaurs rise to the top? One crucial advantage was their posture. As we mentioned, their pillar-like legs made them more energy efficient. Imagine trying to run a marathon with your knees pointing sideways. It doesn't work so well, does it? Another edge was their respiratory system. Many paleontologists believe that early dinosaurs had a type of breathing remarkably similar to modern birds, with a system of air sacs connected to their lungs that allowed for a constant one-way flow of oxygen. That would have been a superpower in the loxygen atmosphere of the Triassic. While other animals wheezed and panted after a short chase, the dinosaurs just kept moving. And finally, we cannot underestimate the role of luck. At the end of the Triassic period, around 201 million years ago, yet another mass extinction event swept across the globe, likely triggered by massive volcanic activity as Pangaea began to split apart, forming what would become the Atlantic Ocean. This event decimated the dinosaurs' rivals, especially the large amphibians and many of the competing archosaur groups. With the competition suddenly cleared away, the dinosaurs were finally free to expand and diversify. And so, from humble beginnings in a world recovering from near-total annihilation, the dinosaurs seized their opportunity. The Triassic period was their crucible, forging them into resilient and adaptable creatures. They were just beginning to diversify. Some stayed small and swift, chasing insects through ancient undergrowth. Others were growing larger, experimenting with new diets, their teeth and jaws adapting to eat the tough plants of the time. And yes, it's now widely believed that many of these early dinosaurs were covered in simple, hair-like protofeathers, not for flight, but for insulation to keep warm during chilly Triassic nights, perhaps for display to attract a mate. It's a humbling thought that what began as simple fuzz to stay warm would, over an unimaginable stretch of time, evolve into the complex feathers that allow hummingbirds to hover and hawks to soar.
Evolution loves to recycle.
As the Triassic sun sets on these first true dinosaurs, we leave them in a world both strange and familiar. A world where survival is hard-won but brimming with potential. They haven't yet grown their iconic horns, their defensive plates, or their titanic size. But their story is now in motion, and the age of dinosaurs is just getting started. Chapter 2. The Jurassic Period, the Rise of Giants. When the curtain lifted on the Jurassic Period, the Earth looked and sounded different. The world was warmer and wetter, and with their main competitors gone, the dinosaurs were ready to inherit the planet's era, lasting from about 201 to 145 million years ago, was the time of giants. It was defined by the flourishing of two spectacular groups, the sauropods, those colossal long-necked plant-eaters that became the largest animals ever to walk the earth, and the large carnivorous theropods, like the fearsome Allosaurus that evolved to hunt them. The Jurassic was also a time of groundbreaking innovation, as this is when we find the first solid evidence of flight in the dinosaur lineage. With the appearance of the iconic transitional fossil, Archaeopteryx, the Jurassic world was a paradise, compared to the arid Triassic. As Pangaea continued to break apart, vast inland seas formed, shimmering under bright skies. The increased moisture in the air allowed lush forests to flourish. Towering conifers, similar to modern redwoods, and pines formed vast canopies. The undergrowth was a thick carpet of ferns, cycads, and mosses. The first flowering plants were just beginning to appear, adding splashes of color to the endless green. With all this plant life, there was an unprecedented opportunity, especially for the creatures that could figure out how to eat it efficiently. Enter the sauropods. These were the long-necked giants of the dinosaur world, gentle behemoths like Apatosaurus, Diplodocus, and Brachiosaurus. If you've ever seen a dinosaur grazing calmly in a children's book, munching on treetop leaves with a sleepy expression, you're probably picturing a sauropod. These creatures were the giraffes of their time, only significantly more dramatic. Some, like Supersaurus or Argentinosaurus from the later Cretaceous, reached lengths of over 100 feet. That's longer than a blue whale, longer than a professional tennis court, longer than most of your local grocery store aisles. How they managed to exist, let alone thrive, is one of evolution's most remarkable tricks. Their skeletons were masterpieces of biological engineering. To support their immense weight, their bones were not solid but were filled with air sacs. a feature called pneumaticity, similar to modern birds. This made their skeletons incredibly strong, yet surprisingly lightweight. Their necks, some stretching over 50 feet long, were supported by a complex system of muscles, ligaments, and vertebrae, and were also riddled with these air sacs, which connected to their advanced respiratory system, allowing them to breathe with surprising ease. And while their heads might seem comically small for such massive bodies, they were perfectly adapted to their lifestyle. They had simple, peg-like teeth, designed not for chewing, but for stripping leaves from branches. They would gulp down vast quantities of foliage, which would then be ground up in their massive digestive tracts. Possibly with the aid of gastrolith stones, they swallowed to help mash the plant matter. Living in great herds and roaming across vast floodplains, sauropods could clear entire forests like nature's slow-moving, biological lawnmowers, and they needed to. Some estimates suggest a large sauropod had to eat several hundred pounds of vegetation each day, just to keep moving. Imagine the sound of one of these gentle giants walking by. A rhythmic, earth-shaking thud of its feet, the occasional loud crunch of foliage, and maybe a low, echoing rumble from deep within its chest, something between a whale song and a foghorn. But not all Jurassic dinosaurs were towering plant eaters. With all that sauropod meat wandering around, it was only natural that predators began to level up. Say hello to Allosaurus, the top predator of the Jurassic, and a fine example of the theropod group, the bipedal, mostly carnivorous dinosaurs. Allosaurus was no slouch. We're talking about a creature up to 30 feet long with a massive skull full of blade-like serrated teeth. Its strong forelimbs were tipped with 3 large, sharp claws that looked like nature's can openers. Its body was powerfully built, and it likely used coordinated tactics to hunt prey much larger than itself, perhaps targeting the young, old, or sick members of a sauropod herd. But predation in the Jurassic wasn't limited to just brute force. Some theropods began showing signs of more refined traits: lighter bodies, keen senses, and yes, feathers. And it's around this time that we find the first solid evidence of a truly groundbreaking innovation in the dinosaur lineage. Flight. Meet Archaeopteryx. Discovered in the 19th century in the fine-grained Solnhofen limestone of Germany, and often hailed as the first bird, Archaeopteryx is one of the most iconic fossils in paleontology. It's a perfect transitional fossil, a beautiful snapshot of evolution in action. It had flight feathers, wings, and a wishbone just like a modern bird, but it also had a mouthful of sharp teeth, a long bony tail, and clawed fingers on its wings. All reptilian features. Evolution was clearly in the middle of a design brainstorm. Whether Archaeopteryx could fly like a modern bird is still debated. It probably could at least glide or flutter between trees like a clumsy pheasant. But more importantly, its existence confirms that birds are dinosaurs, a direct branch of the theropod family tree. Every pigeon you've ever side-eyed in a park is a direct descendant of the Mesozoic's most adaptable lineage, back on the ground. As the continents continued to slowly break apart, dinosaur populations became more isolated, setting the stage for increased specialization. In North America, you might find heavily armored dinosaurs like Stegosaurus, with its iconic double row of plates down its back and a dangerous spiked tail, which paleontologists have affectionately nicknamed the Thagomizer, though it looks like it was built for battle. Those plates may have been more about display and temperature regulation than defense, a dinosaur fashion statement, if you will. Meanwhile, the Jurassic skies were ruled by the pterosaurs, the first vertebrates, to master powered flight. It's important to remember that pterosaurs were not dinosaurs, but close cousins. These creatures ranged from pigeon-sized flappers to species with impressive wingspans and complex behaviors. It's hard to overstate how alien they must have looked. Leathery wings, elongated jaws, and sometimes elaborate bony head crests. They were like dragons, only more scientifically defensible. The Jurassic world was rich, layered, and full of interactions we can only guess at. One of the loveliest facts about this era is how much evidence we have, not just of bones, but of footprints. Fossilized tracks from the Jurassic give us a glimpse into behavior. Herds moving together, predators stalking, young dinosaurs walking safely beside larger ones. The tide has gone out. The Jurassic wasn't just an age of giants. It was a time of movement, adaptation, and glorious evolutionary experimentation. The earth was warm, the skies were busy with flight, and the forests echoed with the heavy footfalls of creatures that to us seem like legends. And yet, their story was far from over. In the next great chapter, they would become even more diverse, more extravagant, and in some ways, even stranger. For now, picture the Earth beneath a Jurassic sun. Sauropods moving slowly through fern forests. Pterosaurs circling over sparkling lagoons, and the distant cry of a theropod echoing across the ancient plains. The age of dinosaurs was well underway, and they were just getting comfortable. Chapter 3. The Cretaceous Period, Variety and Specialization. By the time the Cretaceous period arrived about 145 million years ago, the dinosaurs were not just surviving, they were thriving in ways that would make even the most ambitious evolutionary overachievers blush. The Jurassic had been about growing tall and going big. The Cretaceous was about variety, flair, and extreme specialization. This was the dinosaurs' true golden age. They had claimed every continent, filled every ecological niche, and were evolving into forms both spectacular and occasionally downright bizarre. This era saw the evolution of the heavily armed, horned ceratopsians, the walking fortresses known as ankylosaurs, and the socially complex duck-billed hadrosaurs, and towering over them all was the most iconic predator of all time, Tyrannosaurus rex. This was all happening on a planet that was itself undergoing a dramatic makeover. With the rise of flowering plants transforming landscapes across the globe, the Earth of the Cretaceous looked much more like the one we recognize today, though the coastlines were still messy and unfamiliar. The single supercontinent of Pangaea had finished breaking apart. North America was split in two by a vast inland sea called the Western Interior Seaway. South America was drifting away from Africa, and shallow tropical oceans lapped across vast stretches of what is now dry land. The climate was warm, like a global greenhouse, and sea levels were high, but perhaps the most significant change was botanical. This was the era of the angiosperms, or flowering plants. You might not think of daisies, magnolias, and water lilies as evolutionary game changers, but they were. Before them, the world was ruled by ferns, cycads, and conifers, reliable, but not exactly high-energy snack material. The arrival of flowers and the fruits and seeds that came with them transformed terrestrial ecosystems. They supported new kinds of insects, changed how herbivores ate, and even influenced the evolution of bird and dinosaur species. The Cretaceous was, in many ways, a botanical revolution with teeth. Let's begin with some of the showstoppers of the era, the ceratopsians. This group of dinosaurs includes the likes of Triceratops, Styracosaurus, and Pachyrhinosaurus, creatures that looked like they'd wandered straight out of a medieval jousting match. They had massive skulls, ornate frills, and a dazzling array of horns in all shapes and combinations. Triceratops alone had a head that could span over 7 feet across, one of the largest skulls of any land animal ever. The frills and horns weren't just for show, though. They may have served several purposes: defense against predators, displays to attract mates, and species recognition. Ouch. Nature loves a multitasker. Ceratopsians were built like tanks, with short, stocky limbs, deep chests, and powerful beak-like mouths perfect for shearing tough vegetation. Fossil bone beds suggest they traveled in large herds, and there's evidence of social behavior, including group nesting sites. It's not hard to imagine a great procession of Triceratops lumbering across the Cretaceous plains, their tails swaying, their horns gleaming under a prehistoric sun. And then there were the ankylosaurs, the walking fortresses of the Cretaceous. Covered from head to tail in bony armor plates called osteoderms, and bristling with spikes, they were the ultimate defensive dinosaurs. Some, like Ankylosaurus itself, even had a heavy bony club at the end of their tails that could shatter the leg bones of an attacking T-Rex with a single well-aimed swing. These dinosaurs were so thoroughly defended, it's a wonder anything ever bothered trying to eat them If a hedgehog were the size of a minivan and had a tail like a medieval flail, you'd get the idea. On the opposite end of the defensive spectrum, we find the duck-billed hadrosaurs. These were the highly successful, socially complex herbivores of the Cretaceous. They're often called the cows of the Cretaceous for their abundance and grazing habits. They had complex dental batteries up to 1,000 teeth in some species, continuously being replaced like a conveyor belt capable of grinding down the toughest plant material. Some, like Parasaurolophus, had elaborate hollow crests on their heads that likely acted as resonating chambers, allowing them to produce low, foghorn-like calls to communicate with each other across long distances. They traveled in vast herds, raised their young in communal nesting grounds, and were likely among the most socially advanced of all dinosaurs. But perhaps the most iconic dinosaur of all time also walked the Earth during this period. Yes, the Tyrannosaurus rex, the toothy celebrity of natural history museums, and the reason. Small children can pronounce Tyrannosaur before they can spell their own names. T-Rex was massive, up to 40 feet long and weighing around 9 tons. Its teeth were banana-sized and serrated, perfect for crushing bone. In fact, T-Rex didn't just eat flesh, it chomped right through skeletons, digesting the calcium-rich remains like a walking garbage disposal. There's been debate over the years about whether it was a predator or a scavenger, but the current consensus is, why not both? When you're a 9-ton apex predator, you take the buffet as it comes. Despite its tiny, 2-fingered arms comically, short in proportion to its size, T-Rex had an enormous head, powerful legs, and a surprisingly sophisticated sense of smell. Studies of its brain case suggest its olfactory bulbs were huge, meaning it could probably smell dinner from miles away. Yet, for all its reputation as a terrifying beast, T-Rex was just one member of a diverse family of theropods. Others, like Velociraptor, were smaller, faster, and almost certainly feathered. And while the Velociraptor of cinema was a man-sized menace, the real animal was actually about the size of a large turkey. It was still a cunning predator, with a wicked sickle-shaped claw on each foot, perfect for slashing at prey. Speaking of feathers, the Cretaceous is when they really take off, literally and figuratively. They weren't just a quirky trait anymore. They were becoming increasingly widespread among theropods. These weren't always about flight. Feathers also offered insulation, camouflage, and a way to show off. The dinosaur world might have been a prehistoric fashion show. With elaborate plumage replacing scales and many lineages, the Cretaceous was an age of incredible richness and complexity. The oceans teemed with their own reptilian rulers, like the giant marine lizard Mosasaurus. The skies were still home to pterosaurs, some as large as small airplanes. And on land, early birds were diversifying, filling the skies and coasts with chirps and flapping wings. It was a world full of life, color, sound, and movement. From forested river valleys to open plains, from bustling nesting colonies to deep lagoons, the Cretaceous was alive with a vibrant energy. All of it, every feathered raptor, every armored herbivore, every towering carnivore, is powered by the same forces we see today: the slow churn of evolution, the push and pull of ecosystems, and the endless dance of survival. It's humbling, isn't it, to think that a world so ancient could have been so full of story? The Cretaceous wasn't just a prelude to extinction. It was in many ways the high point of dinosaur life, a final, magnificent crescendo before the inevitable silence. Chapter 4, The Great Extinction, a dramatic exit 66 million years ago. At the very peak of their reign, the world of the dinosaurs came to an abrupt and catastrophic end. Massive asteroid, roughly 6 miles wide, struck the Earth in what is now the Yucatan Peninsula in Mexico. This event, known as the Cretaceous, Pelagian, or KPG extinction event, was not a slow decline but a sudden violent cataclysm that triggered a global impact winter. It plunged the planet into darkness, collapsed ecosystems worldwide, and resulted in the extinction of approximately 75% of all species on Earth, including all non-avian dinosaurs. Let's gently take a moment to appreciate the sheer, almost unimaginable violence of this event. The asteroid, traveling at over 40,000 miles per hour, slammed into a shallow sea. The impact released energy equivalent to billions of atomic bombs. The ground for hundreds of miles around liquefied, and a crater over 100 miles wide was gouged into the Earth's crust. The initial blast would have vaporized everything in the immediate vicinity, sending a titanic shockwave and a wall of heat racing around the planet. But the true devastation came not from the immediate explosion, but from the global consequences that followed. The impact sent trillions of tons of pulverized rock, soot, and sulfur into the atmosphere. As this material rained back down, it heated the atmosphere to oven-like temperatures, igniting global wildfires. Forests that were thousands of miles away from the impact site burst into flame. After the fire came the darkness. The fine dust and sulfur aerosols formed a dense, impenetrable shroud around the planet, blocking out the sun's light. Photosynthesis, the foundation of almost all life on Earth, ground to a halt. Plants withered and died. The world was plunged into a prolonged period of cold and darkness, a scenario scientists describe as an impact winter. Global temperatures dropped drastically. The skies rained sulfuric acid. The oceans, absorbing this acid and choked with debris, turned toxic. In a matter of weeks, months, and years, the finely balanced ecosystems that had supported the dinosaurs for 160 million years completely unraveled. For the large herbivores like Triceratops and Edmontosaurus, the collapse of plant life meant starvation. For the apex predators like Tyrannosaurus rex, the disappearance of their prey sealed their fate. It wasn't a sudden, cinematic collapse where one day dinosaurs roamed and the next they were all gone. It was a drawn-out, agonizing decline, with populations dwindling, habitats fragmenting, survival becoming an increasingly desperate struggle. Only creatures that were small, versatile, or extraordinarily lucky stood a chance. Among the survivors were some of the smallest members of the dinosaur lineage, the birds, thanks to their small size, fast reproduction rates. Their ability to fly long distances to find pockets of surviving habitat, and their varied diets. Some could eat seeds, which can lie dormant for years. Certain avian species squeaked through the extinction bottleneck. They would eventually diversify to fill many of the ecological niches left behind. From the hummingbird to the ostrich, other winners in this terrible lottery included small, burrowing mammals, amphibians that could hibernate in mud, certain reptiles, like crocodiles and turtles that lived in freshwater ecosystems, and deep ocean-dwelling creatures that were insulated from the surface chaos. Being small, able to hide underground, or able to survive on detritus and decaying matter, proved to be a winning formula. Size, it seems, was not an advantage during a global catastrophe. T-Rex may have had a bone-crushing bite, but it couldn't outlast a cold, dark world with no food. So why didn't the non-avian dinosaurs survive? It was a perfect storm of factors. Their large size required huge amounts of food. Their reproductive strategy, laying eggs that took a long time to hatch and mature, was too slow for a rapidly collapsing world. And ultimately, it was a matter of cosmic bad luck. The dinosaurs didn't fail as a group. They faced odds that no creature, no matter how dominant, could overcome. The asteroid wasn't a judgment on their fitness. It was simply a random cosmic accident. What is perhaps most humbling is not that they died out, but that they thrived for so incredibly long before this event. Their story didn't end because they were flawed. It ended because sometimes the universe throws a curveball you just can't dodge. And even then, they didn't entirely disappear. Their legacy lives on, carried in the bones and feathers of every bird. The Great Extinction Event closed a magnificent chapter, but in the quiet, empty world left behind, it set the stage for a new one to begin. Chapter 5. The Secrets to Dinosaur Success. The Dinosaurs. 160 million year reign is one of the greatest success stories in the history of life. To understand their incredible staying power, we must look beyond their size or teeth. It wasn't just brute force that gave them an edge. Their dominance was built on a foundation of key biological innovations: a highly efficient upright posture, a superior avian-like respiratory system, a high-energy warm-blooded metabolism, and sophisticated reproductive and social behaviors. These adaptations, combined, allowed them to outcompete other animals and conquer the planet. Let's start with a surprisingly important upgrade: posture. Most reptiles before and during the time of the early dinosaurs moved with limbs splayed out to the side, a sprawling gait that is inefficient and energy-intensive. Dinosaurs, however, evolved an erect, pillar-like stance with their legs positioned directly beneath their bodies. This wasn't just a fashion choice, it was a revolution in locomotion. It centered their gravity, allowing them to move more quickly and for longer distances without tiring. This upright posture was also a prerequisite. For achieving enormous size, you simply can't weigh 80 tons and drag your belly along the ground. Sauropods could stretch skyward, grazing from the treetops, because their entire skeleton was aligned to support their immense frames like the pillars of a cathedral. Next, their respiratory system was a biological marvel. Many paleontologists are now convinced they used a system similar to modern birds, involving a series of air sacs connected to rigid lungs. Like mammals, which breathe in and out in a tidal, bellows-like fashion, this system allowed for a continuous, one-way flow of air. This meant that with every part of the breath cycle, their blood was being oxygenated. This made them incredibly efficient breathers, a huge advantage in the loxygen environments of the early Mesozoic. Think of it as having biological turbochargers. Forelungs. This super-efficient respiratory system likely contributed to another key dinosaur advantage: a high energy, warm-blooded metabolism. The old debate over whether dinosaurs were cold-blooded like modern reptiles or warm-blooded like birds and mammals is now largely settled. The current consensus leans towards them being mesotherms, or having a physiology somewhere in between, but certainly much closer to warm-blooded. Evidence from their bone structure shows rapid growth rates, similar to modern birds and mammals. Their high activity levels and complex behaviors also point to a metabolically active lifestyle. Being warm-blooded would have allowed them to operate in a wider range of environments, to be active at night, and to live in polar regions where other reptiles would have slowed to a crawl. Then there's reproduction and social behavior. Dinosaurs, despite their size, laid eggs, a strategy that allowed for many offspring at once. But they weren't just mindless beasts dropping eggs and wandering off. Fossilized nests, eggs, and even embryos show a surprising level of care. We have found large communal nesting grounds for hadrosaurs, suggesting they raised their young. In protected colonies, fossils of the dinosaur Maiasaura show adults remaining with their nests, guarding them from predators. There's something deeply moving about that. Picture a massive good mother lizard tending carefully to its nest, nudging eggs with its beak, watching over a crochet of squawking hatchlings. These moments, frozen in stone, speak to a social intelligence we are only just beginning to understand. Finally, we cannot overstate the importance of their sheer diversity. Dinosaurs weren't a monolithic group. They came in an astonishing variety of forms, filling every conceivable terrestrial niche. There were fast grazers, stealthy predators, long-distance wanderers, swamp dwellers, and desert trotters. This ability to specialize meant they could adapt to a wide range of habitats and climates. When the environment shifted, they shifted with it. In the end, it was this complete package of adaptations that cemented the dinosaurs' legacy. It was their efficient posture, their supercharged lungs, their high-energy metabolism, and their complex behaviors, all evolving over an almost incomprehensible span of time. They weren't rushing through history. They had tens of millions of years to evolve, to test new ideas, to fail, and try again. That kind of evolutionary patience is hard for us to grasp. Human civilization is barely a blink of an eye in comparison. Their success was not an accident. It was earned through 160 million years of adaptation and resilience. And their most astonishing accomplishment, perhaps, is that they never truly vanished. A part of them is still with us, a living testament to one of nature's greatest stories. Chapter 6. Fossils and modern science. Dinosaurs remain one of the most captivating mysteries nature ever wrote in stone. And the science of paleontology is the key that unlocks that mystery. It's easy to imagine dinosaurs as creatures of the past, long gone, and wrapped up neatly in museum displays. But the truth is, we are still in the early days of truly understanding them every year. New species are discovered, and new technologies are allowing us to see these ancient animals in ways we never thought possible, revealing not just their bones, but their colors, their behaviors, and their lost world. It all begins with the rocks. Fossil is a rare miracle. When a dinosaur died, it had to be quickly buried by sediment, mud, sand, or volcanic ash to protect it from scavengers and the elements. Over millions of years, as more layers piled on top, the pressure increased, and minerals slowly replaced the organic material of the bones. What remained was a fossil, an imprint of ancient life preserved. In stone, finding these fossils is a challenge. Paleontologists focus their efforts in deserts, badlands, or windswept cliffs in places like Montana, Mongolia, Argentina, and China, places where time has peeled back just enough layers for us to peek underneath. And even then, a discovery is rarely a complete skeleton. More often, it's a single fragment, a knobby bone peeking from a dusty slope. It takes a trained eye to notice it, patient hands to excavate it, and years of research to understand it. Once uncovered, fossils are meticulously mapped, wrapped in protective plaster jackets, and transported to labs. There, the modern magic begins. Paleontologists use fine tools like dental picks and air scribes to carefully remove the surrounding rock. But now, they also use incredible technology. CT scanning lets researchers peer inside fossilized skulls to digitally reconstruct the shape of the brain and inner ear, giving us clues about their intelligence and sense of balance. Synchrotron scanning, which uses powerful X-rays, can detect the chemical traces left behind by soft tissues. This is how we've learned about the color of some dinosaurs. By examining preserved pigment cells called melanosomes, scientists have determined that some feathered dinosaurs had iridescent black plumage, while others had reddish-brown stripes. Computer modeling helps us simulate how these animals moved. By analyzing muscle attachment points on the bones, we can create digital models that simulate their gait, their running speed, and even the crushing force of their bite. We can even model how a dinosaur breathed or how sound might have resonated. In the hollow crest of a hadrosaur, these tools are constantly painting a more vivid picture. The drab, tail-dragging reptiles of the 1950s have been replaced by dynamic, colorful, and social animals. This dinosaur renaissance has revealed that many were feathered, some were vocal, and some were attentive parents. Perhaps the most touching fossils are those that capture a moment of life. Footprints frozen in mud, nests filled with eggs, or a mother curled protectively around her young. In one famous fossil from Mongolia, a small theropod is preserved with its wings outstretched, shielding its clutch of eggs from a sandstorm that buried them both, a 70-million-year-old moment of care, caught forever in stone. These discoveries connect us not just to what dinosaurs were, but to what they were like. They weren't distant alien monsters. They were animals. They nested, they fought, they grew old. Some sang, some strutted, some soared. Paleontology isn't just about bones, it's about imagination, inquiry, and wonder. It asks us to picture a world utterly different from our own, and then dares us to find the evidence that it really existed. And every time a fossil is pulled from the earth, it's like unearthing a sentence in an ancient book, a fragment of a story that is still being written. The study of dinosaurs is not finished, not even close. The past is never truly gone. All around us, waiting patiently beneath our feet for the simple magic of being seen again. Chapter 7. The Cultural Legacy of Dinosaurs. When you think of dinosaurs today, the image in your mind has likely been shaped more by cinema than by science. And yet, these prehistoric titans have left an astonishing legacy that goes far beyond Hollywood. They have fired our imaginations for centuries, evolving from mythical dragons in ancient folklore to the scientifically informed stars of modern museums. Dinosaurs have become a permanent fixture in our culture, our art, and our dreams, serving as a gateway to science and providing us with a profound sense of perspective on our own place in the grand sweep of Earth's history. The human fascination with dinosaurs began long before the term even existed. Ancient peoples uncovered fossils long before they knew what they were. Massive bones unearthed from cliffs and hillsides were often interpreted through myth. In China, they were thought to be the remains of dragons. In parts of Europe, they were linked to giants or beasts from folklore. Some scholars even believe that the myth of the griffin, a creature with the body of a lion and the head and wings of an eagle, may have been inspired by fossils of protoceratops found in the Gobi Desert. It wasn't until the early 19th century that we began to give these creatures scientific names. The word dinosaur itself, meaning terrible lizard, was coined in 1842 by the British paleontologist Sir Richard Owen. The name stuck. Even though we now know dinosaurs weren't lizards at all, and not all of them were particularly terrible. Still, it had a certain flair, and from that moment on, dinosaurs became a permanent fixture in the human imagination. Museums played a huge role in this. The late 1800s saw a boom in fossil hunting, especially in the American West. This was the era of the so-called Bone Wars, a fierce rivalry between two paleontologists, Othniel Charles Marsh and Edward Drinker Cope, who competed to discover and name as many new dinosaurs as possible. Their race led to the description of iconic species like Stegosaurus, Apatosaurus, and Allosaurus. Museums began displaying these massive skeletons, drawing crowds who marveled at these ancient creatures frozen in mid-dash stride. Then came the movies. But the real cultural shift happened in 1993 when Jurassic Park roared onto screens. Its CGI dinosaurs were so lifelike they made audiences gasp. Suddenly, dinosaurs weren't just museum relics. They were alive, fast, smart, and dangerous. Of course, science has moved on since then. For many people, those movies sparked a lifelong interest in paleontology. They turned fossils into celebrities and reminded us that the world is much older and stranger than we often remember. Dinosaurs have crept into every corner of our culture. They appear in cartoons, video games, books, toys, and breakfast cereals. Children seem naturally drawn to them, rattling off names like Ankylosaurus and Pachycephalosaurus, with a level of fluency that baffles many adults. Perhaps it's because dinosaurs tap into something deep in the human psyche, a love of mystery, fascination with the immense, and a sense of wonder about a lost world. But the legacy of dinosaurs isn't just confined to entertainment. They've inspired scientific innovation. Scientists studied dinosaur anatomy to design better robots and prosthetics. Architects mimic the lightweight yet strong bone structures of sauropods. Of course, the study of dinosaurs is one of the best. Public gateways into the worlds of evolutionary biology, geology, and deep time. Perhaps the most profound legacy the dinosaurs leave behind is perspective. They remind us of the vastness of time, of how fleeting our own moment is. Dinosaurs were here for far longer than humans have existed. They survived multiple extinction events, flourished on every continent, and then, in an instant, they were gone. And yet life continued, changed but undeterred. That story, the rise, the fall, the transformation isn't just a prehistoric tale. It's a mirror. A reminder that extinction is part of life's rhythm, that no species, however mighty, is immune to change, and that resilience and adaptability are the real keys to longevity. In that way, dinosaurs are still teaching us about survival, about legacy, and about our place in the grand, strange, beautiful story of Earth. They're not just bones in the dirt. They are whispers from a deeper time, shadows of ancient sunlight, echoes of thunder on a primeval plain. If you listen carefully in the rustle of leaves or the call of a bird, you might just hear the distant heartbeat of that ancient world, still pulsing, still with us, still alive. And so here we are, millions of years, thousands of species, and one asteroid later, at the quiet end of a long and extraordinary tale. From their humble beginnings in the shadow of extinction to their colossal dominance across continents, and finally, to their transformation into the birds that flutter outside your window, dinosaurs were never just ancient creatures of the past. They were innovators, survivors, and architects of entire ecosystems. And though most are gone, their story still lingers in the rocks beneath our feet, the wings above our heads, and the wonder in our imaginations. They remind us that the Earth is ancient, ever-changing, and full of surprises. That survival isn't always about strength or size, but adaptability, resilience, and a little bit of luck. And that sometimes, even the mightiest beings leave behind whispers rather than roars. So as your eyes grow heavy and your thoughts begin to drift, let that story settle in. Let the rustle of ferns, the distant cry of a feathered raptor, and the gentle thud of ancient footsteps accompany you into sleep. Dinosaurs walked this earth for over 160 million years, and in many ways, they are still walking with us now. In birdsong, in fossils, and in our ever-curious minds. Before you drift off completely, I'd love to ask again, where in the world are you listening from tonight? And what time is it where you are right now? Whether it's the early hours in Edinburgh or a midnight breeze in Melbourne, I'm glad you're here. If you enjoyed this quiet journey through time and would like to hear more stories like this, consider leaving a like and subscribing to Science Nap. It helps others find their way here to sleep well and dream of distant worlds.